So we're doing pretty good on participants here. So let's go ahead and get it started. Again, so this is our monthly installation of something we call office hours. And what we do is we pick a topic and then we invite our experts from our field CTO team. So this month, the topic we've chosen is multi-protocol workflows. This is one that's really interesting to me. With my background, I came from object storage. My name is Steve Perchinowski. I'm on the Vast product marketing team. And I'm joined by our two experts, Phil and Scott. Let me go ahead and advance the slide. And Phil just wrote a really great blog on how multi-protocol works with us. And that was kind of the inspiration to do this. And I also saw some other interesting things in the market that are happening around multi-protocol that are driving demand here. So Phil, please go ahead and introduce yourself and tell us what you focus on.
Good morning, everyone. As Steve said, I'm Phil Wagstrom. I'm with the Office of the CTO. We're here at Vast Data. Been with Vast Data now for about 18 months. I focus primarily on multi-protocol and multi-tenancy within setting these up for our customers.
Perfect, thanks. And Scott, tell us what you do here at Vast.
Thanks, Steve. So along with Phil, I'm a member of the Office of the CTO team here, primarily focusing on S3. Been with Vast now for, I guess, about 3/4 of a year, coming from a number of other storage companies before that.
Exciting. Excellent. Yeah, so we've got the right team, multi-tenancy, multi-protocol, S3 object, so we can really cover anything you want. And that is part of the point of what we're doing here today. Our agenda really is all about your questions. So we've got some slides set up, we've got a demo created, but these sessions are so much more fun when they're interactive. So go ahead, type your question in the chat. And what I'll do is I'll then read that and get our experts to comment on it. So let's go ahead and kick it off. This is a quote from Gartner. By 2028, 70% of file and object data will be deployed on a consolidated, unstructured data storage platform. And to me, I think this is about right. I think most vendors on the market today have some sort of multi-protocol application. But one thing I saw that was really interesting, and again, maybe you want to do the seminar or webinar, was that in the last 2 months, like July and August, all of the major cloud vendors announced new ways to move data from object up to high performance file with a focus on AI and ML. And I think that's one of the cool things about what we do here is essentially because we do provide high performance across all of our protocols, that essentially all of your data is essentially always AI ready without having to move it. So again, a lot of momentum in the market here. I think it's just kind of brings up the point of why this is really important. So one of the big takeaways here, and we're going to go ahead and pass it over to Scott, is let's go ahead and define multi-protocol because it's a little bit different depending on who you talk to. So Scott, I'm going to pass it to you.
Excellent, thanks, Steve. So yeah, so I think this is, it's worth level setting here as we start, just to make sure that we're all on the same page. So multi-protocol is one of those things that different vendors will define in different ways and different people define in different ways. So just give me one moment here. I'm just going to steal the sharing from Steve.
Thanks.
So there's a couple of different definitions out there for multi-protocol. So one that you might have heard is, running block and file on the same array. Now, more normally, this isn't referred to as a multi-protocol array. This is normally something you'd more so refer to as a unified system. So different, completely different protocols with really no benefits of sharing those two on the same arrays other than just the fact that you've only got a single system that you need to maintain. So for the purposes of what we're referring to today, that's not something that we would call multi-protocol. The second is where you start to actually share some of those protocols and share access to the same data over different protocols. So an example of that would be where you're sharing NFS and SMB. And that is definitely starting to walk towards multi-protocol access. For some other vendors out there, they can do that for some protocols, not for others. So maybe we have our file protocols being available via shared access, so NFS and SMB, but then object protocols like S3 are kept separate. Definitely a unified, unified setup in the same sense that the first one was, that everything's running on the same array. Stepping into multi-protocol and that you can access some of the data over the same channels, but not what Vast would consider full multi-protocol. So when we talk about multi-protocol, what we're referring to is being able to access all of your data over whichever protocol makes sense for that data at that point in time. So that could be file protocols like NFS and SMB. That could be object protocols like S3. And then that could even be using our new database protocols that we've started to introduce in recent versions of our product, although we're not going to go into those today. They're actually a topic of a previous CTO office hours. So recordings of that are out there if that's something that you're interested in.
So the kind of first two approaches give you some administrative benefits, but not really any interoperability.
Absolutely, yeah. So the first one is absolutely an administrative benefit. You can have one array running both file and block workloads, very useful if you're doing it at a remote site, especially. The one in the middle, yeah, again, begins to give you that, but you're not truly getting that benefit of being able to access everything via whichever protocol you need, which as we go through here, you'll see some of the benefits of doing that.
That makes sense.
And I think we're going to jump into a poll to get a feeling for what people out there are actually doing. So that should have just popped up on your screen. And we'll give a couple of seconds here while people go through and answer that.
Good.
Interesting.
Yeah, I'm the no's really took off at the beginning there. I was kind of surprised.
Yeah, no's were the early
catching up.
leader, but we've started to get some yeses as we go through. Good to see.
Now
Okay, so you should be able to see the results there at the moment. So it looks like we've got about a quarter of the people saying no, they're not doing any multi-protocol. About a little under half are doing yes, but only file and object, and then a little bit of mixing that with object, maybe about a quarter all up. So good to see we're actually getting some people using using all the protocols, which is great. So what do we like to see people doing? Oh, sorry. What do we like to see people doing? Well, of course, we prefer the end one. We prefer option E, everything, everywhere, all at once. And as an aside, if any of you haven't actually seen this movie, I highly recommend it. I actually rewatched it on the weekend. It's an amazing ride, but very little to do with Vast, unfortunately, but it's a great movie.
We're going to bring a little more order to everything all at once, kind of take out a little bit of the chaos, right?
But yeah, great to see we actually do have some people out there doing, especially mixing object with file, which is great to see.
Yep.
So let's just touch very briefly on how we actually do this. And Phil's going to go into some more details on this a little bit later. But as I alluded to before, Vast does allow access to all protocols for the exact same data. And the reason we can do that is partially due to the fact that that's how we were designed to work. And that design comes from what we call this element store. So everything within Vast is stored as not as a file, not as an object, not as a NFS or SMB entity, but it's actually stored as an element, which is basically a superset of all of those protocols. And that allows us to have that sort of full cross-platform access to all of the different protocols that we support. And again, I'll leave this to Phil. He's going to go into this into much more detail as we get a little bit further into the presentation. But why would we want to use multi-protocol? Well, obviously, I guess 3/4 of you at the moment are already doing some level of cross-protocol, so you're already aware of the benefits. But at the end of the day, in my mind at least, it comes down to being able to pick the right protocol for the right use case. And some of the times those protocols are going to be obvious. If you're on a Unix box, then it's probably going to be best to do your access of your data over NFS. If you're on a Windows box, it's probably going to be SMB. Now, there might be exceptions where that's not the case, but the majority of the time, it might be that clear cut as to which is which. And where multi-protocol comes into that, obviously, is the benefit of being able to access the same data over both of those protocols. So let's look at an example of a typical setup that we do actually see a number of Vast customers using. And in this case, this is a life sciences example, but we do see this across a number of different industries. Maybe not using quite as many protocols as we have here, potentially using more, just depending on the exact workload. So in life sciences, it's very common that things like the medical imaging equipment will talk either historically SMB although we're starting to see an increase in S3 there as well. So the various scanners, the various X-ray machines and other diagnostic imaging systems that are producing these massive big files are uploading it to the storage over either SMB or S3. So given that that's what the equipment supports, obviously you don't have a lot of choice in how that data gets sent to your storage. But when it comes to processing that data, often it's easier to do it over NFS. So we might want to be accessing that same data over NFS. Now, if we don't have a multi-protocol system, we'd need to copy that data somehow from our SMB talking system to our NFS talking system, which is obviously a lot of effort to move that data at every step as we go through here. With multi-protocol, we can have all of that data accessible over NFS just as readily as it was written over SMB. As Steve mentioned, AI is starting to be a much bigger thing. And so we're starting to see more and more people wanting to train AI models based on things like this imaging data. And when it comes to AI, what you need is just raw bandwidth to be able to read that data. And the best protocol to do that is normally NFS over RDMA, or what NVIDIA often call GPU direct. Yes, this is just NFS, but running over RDMA rather than TCP, and giving you that fairly significant performance benefit as a result. Then your users may want to actually look at those images, and that's normally going to be easiest done on a Windows box over SMB. Or we might want to distribute that data out to other organizations, at which point S3 might be the best protocol. So again, this is giving us the best protocol for each part of this process. And by having that single centralized storage where all the data is available over all these protocols, we don't need to move the data or make any changes to it as it works through this workflow.
Makes sense.
So what about S3? So I mentioned SMB for Windows and NFS for Unix, but what about S3? What's it best used for? So given we're talking AI, let's go and ask Google's Bard AI bot and see what it comes back with as being where S3 is best used for. And I'm guessing a number of you are familiar with S3. In fact, a number of you said you're already using S3, which is great. But you can see a number of the different things that Bard's thrown back as being where S3 can be a great protocol. And S3 really does take a different model to the other protocols that we've spoken about, in that it's not so much mount-based like NFS and S3. It's much more connection-based, running over standard HTTP protocols, which makes it great for things like mobile applications and cloud-native applications, where you don't want things like trying to mount a directory just to access something. Obviously very common in data lakes. And then we're seeing a large increase recently for backup and restore and archive use cases. Most of the backup software now is moving over to S3, and in many cases preferring that to the NFS or SMB protocols that they used to use. So one of the examples that we had here was mobile applications. So let's actually run through a quick demo of using S3. So in my hand here, I have what everyone's probably got in their hand right now, a mobile phone. So what I'm actually going to do is reach over here and take a quick photo of a few friends that I've got here. And now that photo obviously is on my phone, but I don't want that photo on my phone. I want that photo on my VAST cluster. So how can I do that? Well, if anyone's ever tried to mount NFS or SMB onto an Android device or onto any mobile device, you'll know it's really not a good idea. Not just do the OSs not support it well, but it doesn't work well. Those protocols generally don't work well over things like high latency links and the like. So maybe S3 is going to be a better solution for me, given that Bard's told me that mobile applications are a good use for S3. Well, I'm going to cheat here a little bit and just tell you that actually I don't need to copy that file off my phone because it's actually already done that. So within a second or so of me actually taking that photo, and don't you love doing live demos? Why did that? I don't know, should have worked. Within a second or so of me actually taking that photo, my phone had actually already uploaded it to my VAST cluster. Now, I'll come back in a moment and show you exactly how I did that. But short version, obviously, it was over S3. And I can show you that now on this screen here because obviously if I want to access that file, yes, I could do that over S3 as well because it's been uploaded into an S3 bucket on a vast cluster, but it makes much more sense for me to access that over SMB. I'm running on a Windows box. So that's exactly what I'm doing here is this is access from that same vast cluster running over SMB because that's the more obvious protocol for accessing this file. Now you might notice there's actually a second copy of that file there with -BW on the end, which you might have already guessed is a black and white version of that photo. So where did that come from? Well, when I uploaded that photo, I wanted to do some processing on it, just like I frequently would for data that's being uploaded. So in that case, the easiest way, I'm a Unix guy, so the easiest way for me to do that processing was actually with a little Unix script, mounting that exact same data over NFS, just watching for when a new image gets uploaded and processing that data as it came in. So just to prove that we weren't cheating here, let me go and take another photo and you can actually watch it as it happens live. If I can manage to unlock my phone, which apparently
I'll
I
just
can't.
take a second
There we go.
to remind
Sure.
everybody to please use the Q&A feature to jump in and ask questions. Again, this is live, so we are here to answer those questions and jump in. But I mean, to me, this is just a great demo, right? Number one, love that you've got the elemental figurine there along with the little Vastronauts. Well done. If everybody doesn't know, Vast was the data platform for Pixar. And yeah, so definitely want to encourage you to ask your questions here. This is a just very interesting way this works.
And as Steve said, this is being done live. So just to prove that fact, obviously we can see the times up here, but I actually just took another photo here because I'd forgotten that I've actually meant to have the time visible here in the background as I was doing this. So you could see we weren't cheating. And there we go, 8:18 on Thursday.
Honest demo. Perfect.
So how did I actually do that? Just minimize that one, come back to our slides. So the tricky part, obviously the NFS access there to do my processing in Unix, very easy. SMB access, very easy. Vast is for multi-protocol. What about the upload from the phone? So Android by default doesn't support anything like that, but I actually have a little automation tool on my phone called Tasker. And all Tasker does is you set up basic rules. And in this case, we're just saying that, when a file gets written to the camera directory on my phone, I want you to upload it. The upload rule looks a little bit ugly, but is actually quite simple. Because the thing is, Tasker actually doesn't support talking to an S3 bucket. But this is one of the benefits of S3. S3 is really just HTTP. And Tasker, like pretty much every mobile application and every application on every computer nowadays, supports talking HTTP. So all we've got here is a simple Tasker rule that says when a new file exists, do a HTTP request to this URL and upload that file. Now the URL itself looks pretty ugly, but this is actually a special feature of S3 that's called a pre-signed URL. This URL includes all the details that we need to actually upload that image directly to my vast cluster. It includes the S3 bucket that we're uploading it to. It includes the key that the file, the S3 equivalent of a file name that we want to call it when it gets there. But it also includes all of the credentials via basically a one-time, or not so much one time, but a reusable signed URL that only allows me to do exactly one thing. And this is, again, where S3 has benefits over some of the other protocols, that the security model can be far more flexible than you often see with things like NFS and SMB. In a case like this, where I just want to give access to only upload exactly one image and do it over, a commodity protocol like HTTP that pretty much is available everywhere. So we've taken a product that has no concept of even what S3 is, but very easily made that upload something directly to my vast cluster where I can go and access it over. Next step of the process, accessing it over NFS. And this was the very simple script that was running there that's actually processing my data when it arrives. Now, obviously not going to claim this is good code in any sense of the word or a realistic use case, but point being, I don't need to worry about the fact that this was uploaded over S3. From the NFS side, from the Linux side, it just looks like any other local file system. And then again, same from the SMB side when I went and accessed it.
So Scott, question, are we loose? So as you're uploading that file, there's header information on that file, the device that took it. Do we lose that information because we're putting it on NFS, or are we able to keep that?
Yeah, great question. So really what you're talking about there is metadata. So
Metadata.
Where metadata gets confusing is there's about 3 different levels of metadata involved here. There's the metadata that's in the file, actually in the JPEG file itself. So obviously that's retained, and that's going to be retained regardless really how I move that JPEG file around. But then S3 has its own concept of metadata, and that includes additional fields that I could have set when I've done that upload. Now, in this case, I haven't set any, but pre-signed URLs actually do support doing that. So I could have added a separate S3 metadata field in here, basically saying, photo taken by Scott or photo uploaded by Scott or whatever other data I want to include there. Now, with some implementations, if I'd done this via a gateway, for example, for S3 uploading this to a file system, all that S3 level metadata probably would have been lost. But if you think back to that slide I showed earlier with the element store that Phil's going to go into more details on, because we're maintaining everything as an element, which is a superset of all of the protocols, we keep all of that data regardless of how I'm accessing that file. So if that file gets accessed over NFS, if it gets moved exactly like this script was doing and it gets moved into a different directory, that metadata will come along with the file. On top of that, then we have all the additional metadata of things like the NFS metadata and the SMB metadata, some of which will exist for these files, some of it won't. Some of it will actually be sort of mapped on the fly between the protocols, depending on how we've got things configured. So we still get that security following whichever protocol we're using. And again, Phil's going to go into some more details there. Great question. Thank you.
Yeah, and we actually got a question about security that's coming up. But keep going, and then we'll pause for a second to take some questions.
Yep, absolutely. So jumping back to the same slide we had up before. Now, obviously, that example I just ran through was fairly basic. But if you look at it, it actually maps pretty readily to this exact pipeline we were talking about a moment ago. We had some image capture happening over S3. We had some processing happening over NFS. Didn't quite have any AI training running on my images, but I guess I could have if I wanted to. We had the user interacting over SMB, me pulling up those images and viewing them. And then we weren't distributing it, but that data, again, the process data, including the black and white process version of the image, we could have absolutely made that available via S3, all without us having to configure anything special except just going into the configuration and saying that for this view on the array, it was available via all 3 protocols.
Yeah.
So I'll stop there. Do we have any questions, Steve?
We do. Let's go ahead and jump into some questions here. So, question, everything all at once. So we've got a question about block, and could we do block in the future? It's kind of a roadmap question.
Yeah, it is a roadmap question. It is certainly something we're looking at. It's an interesting one in the sense that from a multi-protocol conversation, because multi-protocol doesn't really play a lot of part in block, because obviously the concepts are completely different.
Right.
NFS, SMB, S3, sure, NFS has a file and S3 has an object, but really they're different names for what is fundamentally the same thing. With block, obviously, it's a little bit different because you end up just having a multi-gigabyte, multi-terabyte thing that is your block device. But it's certainly something we're looking at, and whether we can put any multi-protocol flows into that is absolutely something where we're looking at how we can sort of differentiate over some of the other products out there. So watch this space.
Makes sense.
Yep.
All right, the next one. Okay, this says, it's a question from Matt Weaver. So NFS and SMB have their strengths and weaknesses, often related to the OS in use. When the workload process dictates a less than optimal combination, let's say Mac OS and SMB, Are there other alternatives, such as a VAS-specific driver or protocol stack, or other protocols that could be developed? Media and entertainment loves its Mac OS and the simplicity of SMB. And we do a lot in media and entertainment with the multi-protocol, so I'm curious to get your take.
Right.
Yeah, Phil, if you might be a better one to answer that than me.
Okay.
Yeah. So so the mixing of NFS and SMB really comes down to how do you handle the protocols? How do you handle the security? Yes, there are advantages for either one. To answer the question, is there a specific additional thing that VAST does, or additional protocols that VAST makes use of? The answer to that is, a simple level is really no. I mean, we make use of traditional NFS, we make use of traditional SMB as a protocol, but how we implement it on the back end is really where the magic comes down, where we can go through and control how permissioning is done, define how the permissioning is done, based on the workload that is there. So there's not really any special drivers or anything, or additional protocol things that we can do. It really depends upon what aspects of things we're looking at doing. So, as Scott was talking, we were looking about, using NFS and S3 as a combination. There are certain attributes that can be set via one protocol, but may not be visible from another. The way we implement things in the back end, you don't lose the ability to set those attributes. You just may lose the ability to access them over a different protocol, because that protocol doesn't have that kind of a concept. But to kind of answer your question there, Mike, it's the there's no special drivers or match. But I'd be interested to see if you could cite some specific examples. We can definitely help you with answering those questions.
Yeah, and we are definitely looking at the one you specifically mentioned is one that we know is a bit of a pain point, like macOS and SMB.
Yep.
It's one of those areas that if you went back to my which is best where, you'd actually argue that NFS should be the better protocol, because fundamentally macOS is Unix, but it turns out that's not necessarily the case. We've got some improvements coming there around multi-channel SMB. And we're certainly working on improving the performance with macOS. Not that it's bad, as you say. This is really a generic problem with Mac, not a VAST specific problem as such. But we've deliberately shied away from doing sort of custom drivers or something like that, just because in general they often cause more trouble than they're worth. We do have one exception to that. We do actually have a VAST specific NFS driver that some customers use, that adds multi-path support to NFS to, gives a fairly significant boost to performance. It's actually something we would prefer not to do, but the simple fact is standard NFS hits limitations, especially if you're using TCP, and our systems are fast enough and our customers are trying to push them fast enough that it made sense for us to do that.
Sure.
Our long-term goal there is actually to get multi-pathing support into the Linux NFS driver so that we can stop doing it ourselves, because we don't want to.
Yep. Yeah, that's the key. We want to try to stick with as many standard drivers that are out there. If we have to do a custom, it's because there's a feature that's not quite yet part of Linux. But even so, with the VAST NFS driver, it is still compatible with existing NFS drivers out there. There's not a requirement to go through and use it.
Perfect. So the next 4 questions are all related to permissions and ACLs, and I think that dovetails right into Phil's area. So let's go ahead and, Phil, you fire up, and I'll probably try and hit you with these as we go through, but I'm betting that we're going to cover them. So again, keep asking the questions in the QA.
So while Phil, you can grab the sharing, but while Phil's doing that, let me just hit one of those that isn't necessarily related to something Phil's going to cover around multi-tenancy. Okay. So Sandra asked, can this be configured in a multi-tenant way? And the answer is yes. We do definitely support multi-tenancy. Now, the usual catch, multi-tenancy is one of those things that everyone has a slightly different definition of what multi-tenancy should look like. But we do definitely have the ability to do multi-tenancy, right down to even levels like each tenant can use a separate encryption key when the data's written to SSD.
Yeah, exactly.
But certainly, not the topic we're covering today, but if you want some more details there, absolutely reach out and we can set something up to go through what we can do there.
Mm-hmm.
Great question.
Great.
All right. So everything you wanted to know about multi-protocol file and object, but we're afraid to ask. We're going to hit all the details here.
Exactly. There's a lot of stuff in here. I could go on for a very, very long time on this particular topic is how Vasta implements it. We're going to try to condense it down into the remaining time that we have here. So let's kind of dig into it. So again, we'll come back to this slide here, looking at how Vast looks at multi-protocol, how Vast sees multi-protocol, how we deal with it. And at the protocol layer here, all the different protocols, they are equal level citizens. They have equal performance on that. For that, we don't consider NFS superior to SMB or superior to S3. And even with the Vast SQL, the Vast database we talked about, for that, there is no, one protocol is the primary and another is the secondary in terms of performance. They're all equally performant. They all come into the element store. The element store, as we said, is kind of the key for this, is that the element store is really designed with multi-protocol in mind. It's not designed as like a traditional Unix file system where you're adding additional things onto it all the time. All of the design of it is as an object store with rich metadata, and efficiency with that. So it allows us to do quite a few things on this, and we can take advantage of storing some data that is used by one protocol that it's not visible to another protocol. It's still able to be stored quite efficiently and still able to be utilized by different things such as the vast catalog. So the questions here kind of outline why multi-protocol is really hard to do well. The first one obviously is, well, how do you deal with the different user identifiers that are out there? You've got your UID numbers and your GIDs. If you're doing NFS, you may have UPN, user at domain. If you're doing NFS v4, SMB uses SIDs. S3 relies on public and private keys. These are all different identifiers. You got to, number one, find some way to tie those together. It's great if you can, write data from one protocol as a user, but if you want to do true multi-protocol, you want to be able to access that data as the same user with the same rights and not have a one-off, where I can read more from one side that I can read on the other side, on the other protocol. There's also different permission models. That's kind of where multi-protocol really starts to get difficult and is really hard to do well, because none of this is ever a one-size-fits-all. NFS v3, we all know it has just strictly permission mode bits. Owner, group, another. That's whatever. Read, write, execute for that. NFS v3 or v4 starts to get some additional ACLs. SMB uses NTF ACLs, and S3 even has things called identity policies and even S3 ACLs, which are different still. So how do you handle all those in these kind of environments? That this controls how do you create files? When you create a file, they're using just a UMask. How do you want to define your initial permissions? Are you inheriting it from there? So these are all the difficulties that you have when you're trying to set up multi-protocol, traditionally, that you'd go through and run into. Other things like being able to do if I want to change permissions. Well, I do a chmod from NFS v3. What does that do to ACLs if it has SMB on it? So how do we control that? How do we handle that? And Vast has an excellent approach as to how to go through and handle this. So first off, let's just look at user identities. Well, user identities come down to, you need to determine where they're coming from. So, Vast supports all the traditional ones that are out there right now. Active Directory, we can get our user IDs from Active Directory. We can use OpenLDAP to get user identities from. We can use NIS, if anyone is still using NIS, which aren't very many, or we can define local users. When we're looking at user identities, and at a very simple level, is the way we tie in user identities is to go through and say, hey, give me a common value, like a SAMA account name or a UID name, that I'm going to be able to look at both providers and say, yeah, these two users, this user in SMB is this user in Unix, and we'll put those together and say, yep, this is the same user. So when we're talking about accessing data, via a different protocol, we know that, hey, this user on NFS is this user on Windows, and we can put those two together. Same thing with S3. We go through and say, yep, this user is tied into their S3 key, so when we're doing multi-protocol, they will be able to access their data over S3, and we're not going to grant additional rights or write things out as a nobody user, just because we can't map them out. So very simple.
So there's a couple questions.
Yep.
I wanted to cover a few AD questions here. So sure. The question here is, can we support multiple IDP, let's say OpenLDAP and AD, for the same data set?
So when it comes down to, we can tie together Active Directory and Open LDAP. So if we have, let's say, commonly we're talking about RFC 2307 attributes. So if those are in Active Directory, we can just rely on Active Directory for all that. If those kind of attributes are only in Open LDAP, we can do that. We can put those together where we can get attributes for either from one or the other and define which one's the primary and put those together. When it comes down to having multiple distinct Active Directory type entries, or type providers out there, so we're bound into, let's say, multiple different domains, and where there's not a join or there's not a relationship between those, then that gets a little different, because typically you want to have some segmentation of things there, and we can look at other ways of doing that, with multi-tenancy or with snapshotting and things like that. That's a little more of a complex problem, so I'd have to understand a little bit more what you're looking at when you say multiple providers on there. Generally, it's not something that's commonly done.
Yeah, there's another question here about how permissions are managed with tied to AD. So you answered that question.
And I'm getting to that just now.
Okay. Yeah, exactly. Okay.
So kind of continuing on here. So how do we handle permissions internally? So within VAST itself, the element store actually has a superset of all the different permissions, all the different permissioning types that you'd have for any of the protocols that we support. So we refer to these as VAST ACLs. There is commonality between a read write in NFS v3 and a read in NFS v4, and those will kind of map together. Same thing with SMB, but the VAST ACL, the VAST ACLs are a superset of the types of permissions that you'd have from all the protocols that we support, and these are stored with a single set of permissions for any individual object. And the advantage of doing this as a single set is that, again, when we're doing multi-protocol. For that, we know, that we're not going to be granting additional rights to a user just because we're coming in via a different protocol. They're all going to be defined here. Now, the granularity may be different, for that, but we're still going to be able to, granularity visibility may be a little bit different, but we can still will have those stored on there. Now, what we do then is that for any particular protocol, be it NFS v3 or SMB or S3, we'll take these VAST ACLs and we'll use a well-defined mapping mechanism and a permission checking mechanism to go through and map those out to the particular protocol. So even if I set ACLs over SMB, when I read them on S3, permission is going to be the same as you get on SMB, but these will map out to mode bits and things there. Now, the next question with this here is that, well, how it happens if I want to change things. How do I control changing of things? Because common problem in the world is that, well, if I do a chmod on NFS v3, how does that react with ACLs that are out there, SMB ACLs, NTFS ACLs? So we'll talk about that here a bit in just a second. So the way we do this is that we refer to these as security flavors, and this is really a control here. And here's again the problem is that NFS v3, unless you're using POSIX mode ACLs, which have been around for forever, NFS 3 has no notion of an SMB ACL. It can't set that. In the contrary, Windows doesn't know how to use NFS POSIX bits. It doesn't have a concept of a group owner with that. How do you apply an S3 identity policy to NFS? When NFS only has mode bits for that. Does a chmod changing the ACLs? So what we have here is that we need to maintain flexibility for this. So we've got what we refer to as security flavors, and they'll determine, number one, the permission checking algorithm that's used for this. How do we analyze permissions? Where do they come in? What order do we interpret ACLs in? Things like that. What is the permission model that we're going to use here? We're going to limit ourselves only to NFS permissions with user, group, and other. Are we going to allow setting of those additional ACLs? And then we can control things by saying, well, which protocols are allowed to set those permissions. And then this also, as a consequence here, does define how we create initial permissions on new sets of files and objects. So we have, 3 or 4, we have 4, high-level flavors for this, which really controls how do we set those permissions. So, so NFS. So let's say we want to, have our mode, our primary user that's going to go through and is going to write data and read data for this and wants to control all things or access is going to be just NFS v3. Well, we can go ahead and we can, just use NFS v3 v3 bits, and we can say, hey, just want to do a command on this file, and okay, the user is part of, user is pwags, and I'm part of the engineering group. So that's the way we're going to set permissions there. We're not going to want to deal with any extended ACLs for that, but I still want to access this over Windows. Well, that's fine. We set the permission over NFS. I can come in from Windows, and so long as we can identify that user as being the same user, as being the same pwags user or part of the engineering group, we'll allow access to that. File permissions are then only set and modified by NFS. We don't allow modification via SMB, but it's accessible via SMB. The same thing with S3. If we can identify that S3 key that comes in as saying, okay, this is a user that's either pwags or part of the engineering group, we'll allow them access to read that file or overwrite that file or create a new object in that location. We can do that. Another version of this would be SMB, where we're going to allow for NTFS ACLs to be the rule of length. So we'd set our permissions, we'd set our additional groups, do that all from Windows, and then we would be able to modify those and change those from Windows clients, and then I could go through and read that from NFS. That's go from there.
There was a question about, will the metadata and ACLs be preserved from include SMB ACLs? So that's a yes.
Yes, yeah, it will be preserved. So with this here, we're talking about all the metadata for this. So even with NFS, it's going to come down to, if we are doing a move of an object for things, then yeah, that will be preserved because that's part of that particular object, that particular file that's associated with it. If we create a new file over NFS, or we create a new file over SMB, then the metadata for that, may not be there. When I say we create a new file, it depends. If we're trying to do a copy of a file from NFS and then rewrite out a new file for that, then we may not get that metadata for it because it's a new file. But generally, if it's we're manipulating the same object without creating a new object, all those permissions are going to go through and be preserved for that. Or in the case of creating new files here, if we got SMB ACLs that are associated with the directory I'm creating things the file creation is going to follow those SMB type rules for file creation.
Makes sense.
Okay. So the other objects here is that we can use an option of mix last win, and this is kind of the everything where you want to be able to go through and use NFS v4 and NTFS ACLs. You want to be able to set those from both sides, from SMB or Windows for that. This requires that users understand how to go through and do an NFS4 set facle or NFS4 get facle to make those modifications. For that, and you're going to allow them to go through and do that. Other things that, things like if you're using NFS v3 in this kind of a setup, NFS v3 will only be able to modify just the trivial mode bits, and there's specific ACLs associated with just those trivial mode bits, and it'll leave the rest of them alone. So you've got flexibility with that. If we can use also an S3 native flavor, where the rules of file creation are, again, they're going to be dictated by S3 ACLs, where S3 has its own unique set of ACLs there. These will be represented to NFS, or they'll be represented out to SMB, as a set of permissions that are on there, but they are defined by S3. They're controlled by S3, whether it be identity policies, or the ACLs, and then access is granted or denied from those. Now, from any one of these protocols, you may not be able to see the permissions, for that, because again, NFS v3 doesn't have a concept of some of these, concept of all these extended ACLs, but they're still going to be enforced because again, this is all part of the actual object that's part of their on the vast ACLs. So they'll still be enforced regardless of the protocol that's used for that. Okay, so what kind of questions here are those we can kind of go, wrap up with some of these here. Steve, do you have any here? Others I can kind of read off.
No, I keep going with this. I've got some other questions I think will come in at the end.
All right, sure, sounds good. So when we're looking at flavors here, the great thing about the security flavors is that you don't have to set one, and that's the one for the entire platform, the entire vast data cluster. You can set this on a particular view by view or share by share basis. So we can go through and use, if your primary use case is, SMB home directories, but they may want to access that over NFS. You can use the SMB security flavor. The primary use case is that this is an NFS home directories there, but they want to access over SMB. You can do it the other way with an NFS security flavor for that. So you want to look at how is my data coming in? Which protocols are going to write the data? Which protocols are going to go through and use to read this data or access this data or manipulate this data? And then the next question is, well, what model makes the most sense for permission? How complex do you need this to be? If mode bits are all that you need, great. That's perfectly fine. Just use the user mode bits, use the NFS security flavor, and that's good. If you need more granularity for additional groups, well, with NFS security flavor, you can add POSIX mode bits in there or POSIX ACLs in there to it as well. If you want to have the additional ACLs granted by NFS v4 or SMB, you could use mixed last wins for that. If you need to have you want things to be controlled strictly under S3 rules, you use the S3 security policy. And then the last question is, well, which permissions should permission changes be allowed after file creation? And which protocols do you want to allow those permission changes to be done from? So we can go through and restrict, say, no, I want to have these only controlled by Windows. I don't want POSIX mode bits to come into play at all here. So we're going to just control those from Windows. So we just use the SMB security flavor, and we block changes to permissions from NFS. So we can control this. And we can do this on a view-by-view basis, or actually we call this as a view policy basis, but we can do this on a view-by-view or share-by-share basis. And then, of course, the final question is that do the users themselves understand those ACL complexities? If you want to go through and turn everything on and do something like mixed last wins. If you don't want to have, if they don't, and you don't want to have them hear that, then you can go through and say don't want to turn off the ability to change permissions from one protocol to the other. So lots of options here for this, and that's the flexibility here is the key for setting these up there.
So there was a question about with SMB, you got AD, with NFS, you got OpenLDAP, and they may have different UIDs and GIDs. How do we map that?
So in the case where you have situations where you've got different UIDs and GIDs, depending upon how you're looking at depending on how the user's accessing the data, we can go through, and there's two different methods we can leverage. So anytime we go through and we set up different providers, we put those providers together as part of a tenant. And again, one of the nice things that VAST was designed with multi-protocol in mind is also designed with multi-tenancy in mind. So creating a tenant is very, very simple. But we can set for any particular combination of Active Directory or OpenLDAP which one we want to have be the primary. So if there is these kind of conflicts that arise on there, we can say, well, this is going to be the primary resolution for those POSIX attributes. Always rely on the LDAP to say this is the UID that's used for that, or always rely on SMB saying this is the AD that is used. And if a user doesn't have that representation in AD but does only an OpenLDAP, well, we'll use the one from OpenLDAP. So we can fall back to the other one. But if there's conflicts, we can say how we're going to resolve those conflicts. And for those cases where we have multiple combinations there, we can easily set up multiple LDAP servers, multiple Active Directory servers to communicate to, and just put those in different combinations in different tenants to give that kind of access and allow that kind of access, and obviously with different views from that.
That makes sense. Got another question here from John about KRB5i and KRB5P options for client auth. Is that supported?
Yep, absolutely. So we do support for NFS v4. We do support 5i and 5p for that. We do also support doing NFS over SSL for that, for both NFS v3 and NFS v4. If you're looking for something that one of the difficulties with 5i and 5p is that it does require a bit of overhead with that. If you're doing that over SSL to get the encryption abilities on it, for that, then we can make use of SSL to do that as well.
Okay. So here's another interesting question. Do you offer an optimized backup solution that operates using your proprietary underlying data format versus a standard backup that works over NFS or SMB? So
Yeah,
I think I know how I'd answer that, but
yeah. So today we don't. We do work with a number of backup vendors, but the approach to date has basically been using Vast as a target for the backup rather than focusing on the source. But that said, we are absolutely working down that path at the moment. So working on tighter integration with a number of different backup vendors, using a number of different features in the product, including things like capturing those additional details that we have in the element for the data rather than just the NFS or SMB view of the data, as well as using things like our vast catalog and other functionality we have around being able to determine what needs to be back up, what's changed, and basically minimizing the amount of data that we need to back up. We do actually have a feature that we call backup to S3, which does actually do what you're asking, which is taking basically all of our element data and backing it up to an S3 server. It works brilliantly. It does absolutely copy out all of that data, but it is, just because of the way it works, it is a little bit limited in what the use cases are for it. But certainly that's the approach that we then want to take to, we have the ability to do that. We just now need to get that integration with the backup vendors, which, as I said, we are actively working on.
Yeah, and that's obviously in addition to just the native replication that Vast can do between different Vast clusters for purposes of backup. So, and then the one last question, they're talking about the behavior on multi-protocol shares when there's a file system, file system only, things like symlinks. There actually are different notions of symlinks when you're looking at, when you're looking at a symlink as it relates to NFS or as it relates to SMB. SMB does have something very similar to a symlink there. With a lot of cases there, it depends upon how they're created and what type of symlink is done. So we do support fully symlinks with NFS, created over NFS, and those are followed on SMB. That is perfectly fine to go through and do. We do also support those symlinks when related to when created over SMB to be followed on NFS as well. There's the symlink notion on SMB and Windows in general actually can be is kind of somewhat overloaded. So there's things called reparse points and things there. But if we're looking at creating a link for saying, this is a link from this file to this file, or from this directory or this folder to this other folder, for that we definitely do support that for SMB, and those can be created over SMB and followed and represented over NFS type access as well. So it really depends upon. So we do support that at that. For some of the more complicated notions of that, it depends on what the approach is.
Makes sense.
Okay.
All right. Well, that's it. And thank you for your questions. This is exactly what makes this a great discussion. Let me go ahead and just share my screen real quick. So. Again, if you've got questions, jump in, or again, reach offline if there was a question that you didn't want to ask. We're glad to dive into the details here. This is a complex subject. And I'll put a link to in the chat here to Phil's blog, which also dives into a lot of this, and that may drive some more discussion. So one thing I did want to ask you a favor on is, we're really proud of our participation in the HPC community. HPC Wire every year puts out these awards. So if you would go ahead, and I'll send you the link to so you can vote on this. But if you would vote for us here, we would certainly appreciate it. Let me go ahead and pop that link out here. And there we go. So again, follow that. Go ahead and please vote for us on one of these or all of them. And if you want to know more, you can always go to vastdata.com/platform, or again, reach out to us here. We're glad to follow up and set up a discussion with the sales team. For me, this was, something that, my background is somebody coming from the object storage world. This was something that people always wanted. I think Vast just has the most elegant way of doing it. So it's one of the things that I was really excited for. So I want to thank everyone for attending. I want to thank Scott and Phil for your time on this. This is, again, great stuff. And thank you so much, everyone, for attending today. And we'll see you in the next one. Take care.
Thank you, everyone.
Thank you.